Okay, well, 3.5, here we go, last section in chapter 3. So this goes back, just a pretty simple example. All we're doing is subtracting 8.25 from 11.04. And obviously you can do this on your calculator, and the only point I want to make here is, again, when you add or subtract, you can only add or subtract the same units, which we saw this in fractions, and now we're going to see it in decimals. So, anyhow, 0.25 means 2/10, right? 2/10 and 5/100. There's the exponential notation, and there's what it represents if you look at it in terms of money. So, on this one, I'm going to have to regroup, right? Because you can't subtract 5 from 4. So I can't regroup from here, but I can take one of these. These are ones. So I'm going to take one of those and move it over here. And what I'm doing is adding 10 to here. I don't have any, but I'm adding 10. Because one whole is 10 dimes. And then I'm taking one of those 10 dimes and moving it over to here, which becomes 10 pennies. So I can get 14 pennies there. So 14 minus 5 is 9, right? So now it's just, I am subtracting pennies from pennies. And now here I'm subtracting dimes from dimes. This regrouping allows me the whole system to work. So 9 minus 2 is 7. And then I can't take 8 away from 0. These are ones, right? There's the decimal point. So I'm going to take one $10 bill. No, I have no $10 bills. Move the $10 bill over here and change them into $1 bills. So now I can subtract. 10 minus 8 is 2. So the answer is 2.79. And that's how the whole system works together. So this example, I'm just going to convert this decimal into a fraction. And there's a shortcut to it, and then there's a long way. I'm going to do the long way to start. This here is 4/10. So I have 4/10 plus 300 plus 0,000 plus 5 10,000. So in order to add these, we have to find a common denominator. So I'm going to take 4/10 and change it into 10,000. So my denominator, when I'm done, is going to be 10,000. So I'd multiply this by 1,000 over 1,000 and get 4,000. So I've got 4,000 here. I'll put it over here. 4,000, 10,000. Plus, and now I'm going to take 300, multiply it by 100 over 100, because 100 times 100 will give me 4 zeros, right? So I get 300 10,000s. Put that here. And finally, I have 5 10,000s. And I'll put that there. So I got 4,305 10,000s. Now, is there an easier way of doing that? And the answer is yes. Because you're always going to have the common denominator of the last decimal. So that's the 10,000s. And then you can almost just read it off. 4,305 10,000. There's one more zero, or one more times 10 in the bottom than there is in the top. So that's an easy way of doing it. Now this is a good question. And the answer is they're all equal. And let me explain why. This is just 9/10 This one here is 9/10 plus 0 hundredths plus 0 thousandths. So it's just 9/10. Adding 0 to a number doesn't change it. And the final one here, that's 9/10 plus 0 hundredths plus 0 thousandths plus 0 10,000ths. So you can see all these are equal. And it just comes from understanding how numbers are constructed. Now, I'm not going to ask you to, most of the time, not to do this on a test, right? But I'm going to change these fractions, this one and this one, into decimals. And the way you do this is well, there's two ways. This way is easier. All decimals, right? Any decimal, 0.72, 0.857, any decimal has a denominator that is a power of 10. Right? 10 to the negative 1, 10 to the negative 2, whatever. They all have powers of 10 as the denominator. So 20 is an easy one because I know that 20 times 5, you should know, 20 times 5 is 100. So I can multiply 7 over 20 by this form of 1 and get 35 over 100. 35 over 100 you can simply write as 0.35, right? Hopefully you can make that connection. But if you can't easily get the denominator to some power of 10, you can always divide it and sort of force it into the system, into your decimal system. Now the first mistake you don't want to make, it's 3 divided by 11, not 11 divided by 3, right? So you set it up this way. There's no ones, which that should tip you off because that's less than 1. So there's no ones here. So the next place value is the tenths. So what you do is add a 0. But the reason you add a 0 is because you're changing 3 wholes into tenths. And that would make it 30 tenths. So that's how many tenths there are in 3. How many tenths can you fit in there? The answer is 2. So that's 22 tenths. I subtract, see what I have left over. I have 8 tenths left over. That is actually 8 tenths. Now I'm going to add a 0 because I'm going to change tenths into hundredths. By multiplying by 10 over 10, I get 80 hundredths. So how many can I get in there? And the answer is 7. So 7 times 11 is 77. And I have 3 hundredths left over. That's now hundredths. So that's how many tenths, that's how many hundredths. Now I'm going to be into the thousands. So again, I add a 0 because I changed 3 hundredths into thousands. And I get 2, which is 22. 2 times 11 is 22 with 8 left over, and I think you can see this is going to repeat. So 3 11ths is 0.2727 repeating. The way we write that is 0.27 repeating. So in this problem here, it's really a small leap from what we did in a couple sections ago, like 12 times 1,000. You would move the decimal 3 places or add 3 zeros. This one, we have the decimal and then we have numbers after the decimal. We're multiplying it by 1,000, which is 310. So that will move the decimal 3 places. So there's where it is now. There's moving it once, moving it twice, moving it 3 places. So it's pretty simple to multiply with decimals if you have a power of 10. Calculators and spreadsheets often display, for example, this is the way your calculator, you probably would put it in your calculator. And it often displays it like this, which means the same thing, okay? So this is 12.67 times 10 raised to the third power. 10 raised to the third power is 1,000. This is 12.67 times 10 raised to the third power, which is the way your calculator often displays this notation. E means times 10 raised to the, in this case, 3. So this is going to be the same as above. Whoops. 12,670. Same as this. Just another way of looking at it. So now we're going to divide by powers of 10. So I'm going to take 6.23 and divide it by 1,000. And yes, it moves the decimal 3 places, but we already have a decimal here, right? So I got to move it 3 places that way, make it smaller, right? So there's 1, 2, 3. There's a decimal, and I'm going to backfill with zeros. So the answer is going to be 0.00623. That is also can be written as, watch this, scientific notation. You get one decimal, a whole number, and then the decimal. So I can move it 3 places to get one decimal. But in order to do that, I need to compensate, which is that. So that means move it 3 places to the right. This is 1,000. So that number there is the same as this number here. So this would be quite easy to do on a calculator. I'm going to show you the trick that's used when you don't have a calculator. You're just doing it, just the idea of how the pattern works, all right? Nobody multiplies 2.6 times 3.4. What they do is multiply 34 times 26. Now, it's not the same problem, right? But to go from 2.6 to 26, I have to multiply 2.6 by 10. And to go from 3.4 to 34, I have to multiply 3.4 times 10. So I'm basically taking this problem, moving the decimal 2 places. So this problem here is 100 times bigger. The answer will be 100 times bigger than what the answer is for this problem. But this problem is too hard to do, and let me just give you a quick illustration of why that is. This would actually be 4/10 times 6/10, and 4/10 times 6/10 is 24 hundredths. So then this is 4/10 times 2. 4/10 times 2 is 8/10. And I could keep going. I could literally do it this way, but what a pain, right? So instead, we multiply the problem by 100, multiply it out, and then divide it by 100. So multiplying it the way usually taught, 6 times 4 is 24. Carry 2 tens over. 6 times 30 is 18 tens. 2 more is 20 tens. I put a 0 down here because that's a 20, not a 2. And 20 times 4 is 8. 80, right? And 20 times 30 is 600. So I get 884. That's the answer to this problem. But it's not the same as the problem I had, right? The problem I had is up here. So what I'm going to do is move the decimal back 2 places. 1, 2. So the answer to this problem is 8.84. Yeah, most of the time we're going to put these in our calculator. But sometimes there's a couple little tricks you can use. So the one trick I'm going to use is that I'm going to multiply the numerator by 10, or the numerator by 100, 1260, and the denominator by 100, 63, right? Move the decimal 2 places, this number here is exactly the same as this number here. Because the only thing I did was take this number and multiply it by 100 over 100. So whatever I got, I multiplied it by 1. So these numbers are the same. Now I'm recognizing here that 63, 2 of these is 126. So I can write this as 126 times 110, because that's where the 0 is, divided by 63. This is 2. Divide that, I get 2. 2 times 10 is 20. So there's occasionally something you can do. With division, though, you're really kind of changing the number to another equivalent division problem. So this one just says estimate. Estimate. So I'm going to estimate it really quick. This is close to 1. This is close to 2, right? Closer to 2 than it is to 1. This one's close to 5. This is 10. That's my estimate. You want to estimate as quickly as possible and get a rough idea. And so that's how you would do it. 0.8 is closer to 1, closer to 2, closer to 5. So I just want to give you some hints on these problems here. It says add or subtract is indicated. 5 raised to the negative 1. That means 1/5, right? Or if you want to make it a decimal, that's 2/10 or 0.2. 7 of 10 to the negative 1. That is 7/10, right? So I have 2/10 plus 7/10, which is 9/10. Or you can write it like this. So I'll just write what these are and I'll let you work it out. This is 6 of 10 to the negative 1. So that's 6/10. Or you can write it like this. And that's plus 5. And I'll leave that for you. Don't forget the plus sign. These should be quite simple for you. We're dividing or multiplying by powers of 10. I'll just do a couple, right? Here is 22.3 move 2 places. So that would be 2, 2. There's 1 place, there's 2 places. This is, and just for your 10 to the negative 1 is the same as 1/10, right? That's the same as dividing by 10. This is the same as dividing by 100. 10 to the negative 2 is 1/100th, right? 6 divided by 2 is the same thing as 6 times 1/2. So this is going to move the decimal 2 places. 1 place here, 2 places here. So 0.65 times 1/10 is the same as 0.65 divided by 10. Move the decimal 1 place, I get 0.065. Here I'm going to move it 2 places, I'm going to get 34.50. All right, that's the main thing here, is understanding what this is here and this here. So here we're changing from decimals to fractions and fractions to decimals. And remember, like this one here, you don't have to do it the long way. There's 2 numbers to the right of the decimal, so there's going to be 58 with 2 zeros in the denominator. That's the shortcut of doing it. The long way I did it, I said, well, that's 5/10 plus 8/100. I can change 5/10 to hundredths by multiplying by 10 over 10 and get 50/100. And that's fine. 50/100 plus 8/100 is 58/100. So I'm going to get the same answer by this long convoluted way. But if you can recall what I did here, 2 decimals to the right, 2 zeros in the denominator after the 1. So I think you can handle most of these. This is the one you're going to have to divide, right? You're going to have to go 5 divided by 8. So you get one problem like that. And did I do it right? Yes. Don't do this. That's 8 divided by 5. 1 point. That's not right. So make sure your setup's correct, right? These are right from what I did earlier. And I'll just do one of these. So this one here, I'm going to get rid of the decimals. So I am not changing the problem. I am just simply going to change this to an equivalent form. Get rid of the decimals, I need to move it 2 places. So that's 100. Anytime you multiply by 1, it doesn't change the number, it just changes the look of it, right? So moving this twice, I'm going to get 340 divided by 17. That's moving it twice. So this is going to be 34 divided by 17 is 2 with 1 0.